We are starting a new chapter called as Problem Solving Methodology. This is the most important chapter in your entire syllabus of first and second year. The reason this chapter is important is because it tells you what is the approach in order to solve a problem using algorithms and flowchart. Algorithms and flowcharts are important because they help you develop programming logic skills in the sense given a problem how to break it down into a number of steps and find the solution. Those skills can only be developed by learning algorithms and flowcharts. So, in this chapter, problem solving methodology, it is divided into three parts. Part 1, I'm going to talk about algorithms. Part 2, I'm going to talk about flowcharts. And part 3, I'm going to talk about the different statements or constructs which are used to solve a given problem in any programming language. So first let's start and try to understand what do we really mean by a problem. A problem can be any statement or any statement of fact or a definition which requires a solution. It need not necessarily just be a maths problem. It could be a problem in any field or any domain. Let us now restrict ourselves to solving problems using a computer. If we have to solve a problem using a computer, there are a series of systematic steps to be followed. The first step is defining the problem very clearly. The minute you define a problem very clearly and understand it, finding a solution is rarely very difficult. Most of the time, with experience, you'll notice that understanding the problem itself is a lot more difficult than finding a solution. The next is digging deep into the problem, understanding what the problem is all about, what is the inputs, what is the output, okay, what are the requirements. This is problem analysis. Algorithm is a way of solving a problem in a finite amount of time using well ordered steps or sequence and finding a solution. So we will talk about algorithms and flowcharts in detail. Just understand that it's a problem solving methodology specifically used in computer science. Then after you develop the logic, you are going to write the code in any language like C, C++, anything and so on. After you write the code, there is no guarantee that that particular code is perfectly correct. So what you will do is you will test and try to figure out errors in that code. Once the testing and error removing is done, that particular code can be used in the real world. After that, you will document all your activities you have done so that people who are going to use it later, who are going to modify it later, do not find any problems in using that particular application of yours. Then what about maintenance? When you use an application, the legal requirements can change. The users may change, the users needs may change, new laws may come into picture. So you will have to constantly keep making modifications to the application, making changes to the application so that the application is useful over a long period of time. Because government could bring in new rules, like say for example, you have 70 sleeper seats in a train bogie, let's say. Suddenly the government decides to reduce it to 60. Then the whole way your logic works has to be modified. This is an example of a maintenance. So let us first try to understand what do we mean by a problem definition. Okay, so let's try to take an example. Let us say I want to find the area of a triangle using Hero's method. So the first thing is, what is the clear definition of the problem? It is trying to find the area of a triangle using Hero's method. Now the question is, what is to be done? How it is to be done? What is to be done? I need to find the area of a triangle. How can I find it? I can find it provided I know the length of the three sides A, B and C, as well as the half perimeter S. Once I know those three sides, then it is easy for me to calculate the area of a triangle using Hero's method. We will be talking about Hero's method a little later on. For now, just understand it's a way of solving a area of a triangle. Now, it's asking us what data do we require. The only data we require from the user is the length of the three sides. Let us call it as side A, side B, and side C. Where do we get this data from? Let us say we get the data from people like me and you. Whoever is going to use the program to calculate the area of a triangle is going to get the data from us. What is the input? The input happens to be the length of the three sides. What is the output? The output should be the area of a triangle calculated and printed. What are the interactions it should do with the user? The two interactions it should do with the user is in the first interaction, it should ask the user to enter the length of the three sides A, B, and C. And finally, what is the last interaction? It should print the result on the screen. So, if you see here, in order to find or solve a problem, you need to define the problem very, very clearly. Then solution is really easy. So once you have a clear understanding of the problem, then you can focus on the actual parts of it and eliminate issues or parts which are not important. This is a skill you will develop over a period of time as you begin to write more programs. Initially, the biggest challenge students face is trying to understand the problem clearly. And part of the reason for this is we have all been brought up in a culture where we are taught to memorize things, learning by heart or learning by rote. From this chapter onwards, I strongly advise you develop an habit to understand everything. Once you understand computer science, it is the easiest subject. You cannot learn by heart or by rote. It is the reason why children falter or trip learning computer science is because they come with the preset mind of learning things by rote. This is a subject which is very simple, which you can easily learn by understanding it. So make an effort to understand. So understand the problem, what are the inputs, what are the outputs, what is the data required, what are the interaction, ask all these questions and then go ahead to solve. What is problem analysis? Okay, analysis is further digging down deep into the problem. What is the input data to work with? Input data is again sides of a three triangle. What are the expected or desired results? So if the side of the triangle is entered, I should get the correct result. So I should be able to, using pen and paper, write the three sides and calculate the area, and whatever program I write should also give me the desired sides and desired area and output. Now if there are any specific requirements or constraints, even in this area of a triangle, there are specific restrictions. For example, if a triangle has to be valid, the sum of any two sides must be greater than the third side. If you enter a triangle like 1, or let's say 10, 200, and 1000, this is not going to be a valid. The reason being the sum of any two sides is not greater than the third side. So this is a restriction on that. So I've just briefly talked about problem solving, problem definition, and problem analysis. This is all theoretical. Just need to understand. I doubt there are going to be any questions ever on this. But from the next session onwards, it's really important because I'm going to talk about a method called as algorithms to find solution to a given problem.